Okay, in this video, we are going to talk about radioactivity. Now, the old video I talked about, we are talking about atomic physics. So make sure you watch the previous video before coming to this video. Anyway, those who have been following this video, today we are discussing about radioactivity. Okay, so first, of course, we need to define what radioactivity is. Radioactivity can be defined as the emission of radiation by a substance. Okay, you can also define radioactivity as the spontaneous process of an unstable nucleus emitting radioactive emission in order to become more stable. Okay, so this definition can simply be explained saying it is said to be spontaneous because it is neither affected by physical condition nor the chemical condition, so it just occurs naturally. So it will occur naturally. That's what we call what radioactivity. So it is spontaneous because not affected by physical conditions or chemical conditions, but to just occur naturally. So that is what we call radioactivity. Okay, so under radioactivity we have got this subtopic which we call radioactivity decay. So to define it, this is a process by which the unstable nucleus breaks down, releasing radioactivity. Simply, it is straightforward. That one is simply straightforward. So we move forward to what we call types of radiation. Types of radiation. Okay, there are simply two types of radiation which we are going to discuss today. The first one, it is called natural radiation. Anyway, just from the definition itself, natural, we can say people can even understand by saying natural. Okay, this is a type of radiation that takes place spontaneously. Okay, so spontaneously it occurs at any time. Okay, all atoms with their number the atomic number greater than 83 are naturally unstable and will undergo natural radioactivity decay. So here you can bear with me, you can just go to the periodic table where we find all elements having the atomic number greater than 83, they undergo what we call natural radiation. Okay, that is the first type of radiation we have, which we call it natural radiation. The second type of radiation we have is simply called artificial radiation. This happens by making the nucleus stable. So it means artificial is simply caused by someone. Okay, it is simply caused by making the nucleus unstable, then the radiation will simply occur. Okay, um, then from there we move forward to what we call types of reductive emission. Types of reductive emission. So we've got three types of reductive emission. The first one is there, which is simply called the alpha particle, with that symbol there simply representing alpha. Okay, so these are particles which consist two protons and two neutrons bound together. So alpha particles, they simply have got two protons and two neutrons bound together. Okay, they are represented by the helium symbol. Okay, remember what we did on under atomic we said helium has got two electrons and or two protons, and the mass number is simply 4. Okay, so the alpha particles are positively charged. They are positively charged. Keep that in mind. They are positively charged. Can we go to the characteristics of uh, of alpha particles? Okay, how can we describe an alpha particle? How can you identify an alpha particle? So we can simply say characteristics of the alpha particle. The first one is what we call they have a positive charge. They have a positive charge, which is +2. Since an alpha particle contains a proton and a neutron, remember a proton has a charge of positive. Therefore, since they are falling under a helium atom, they have a positive charge which is +2. They have a positive charge of +2. Okay, then they have a large mass of 4. Remember, we said alpha particles are represented by helium symbol, and the mass is simply 4 for helium. So therefore, all alpha particles, they have a mass of 4. Okay, the next thing is they ionize strongly. They ionize strongly. The next point is they arrange in air is very short. Their range in air is very short, which means they don't go a long range once they're exposed to air. So their range in air is very short. And they have now another point is they have a weak penetration and can be stopped by a paper. They have a weak penetration and can be stopped by a paper, which means if an alpha particle is coming, then you just put a plain paper or a paper. They won't penetrate through, they will be stopped, they won't go through. That point means that they can be deflected by both magnetic and electric field. I'll explain that point as we go forward. Okay, we go on to the next type of of reductive emission. We've got what we call the beta particles. Remember I've said reductive emission, we've got three types. There's beta particle, alpha particle, and gamma rays. There we described the alpha particle. Now we are here to describe the beta particle. Okay, these are fast moving electrons that are negatively charged. So from here you can just notice the difference between alpha particle and beta particle. You can see that the beta particle are negatively charged while the alpha particles are positively charged. So these are fast moving electrons that are negatively charged. Okay, a beta particle has a small mass and as compared to the alpha particle. So these have got a small mass as compared to the alpha particle. Okay, features or what we call characteristics. How can we describe a beta particle? The first one is saying they have a negative charge. They have a negative charge is -1 there. Then they have a mass of 1 over 1800 or 1 over 1840. Okay, we can adopt 1 over 1800 at this moment. Okay, then again they have low penetration. They have low penetration and they have weak ionization power. If you compare the alpha particles, they have got a strong ionization power. Then these, they can only be stopped by the aluminium sheet. So they cannot be stopped by the aluminium sheet, which means beta particles can penetrate through the paper. Okay, meanwhile alpha particles can't penetrate through the paper. Beta particles will penetrate through the paper and they won't be stopped by the aluminium sheet. Okay, can we now go to the last discussion of today's video, of today's lesson I mean, so that we see what follows there. The next thing is the gamma rays. The gamma rays, these are not particles. Okay, these are not particles, these are waves. Remember, from electromagnetic waves we find gamma rays there. So these are not particles. Please don't say gamma particles, you have to say gamma rays. The symbol is there. Okay, they are waves that are similar to X-rays. Okay, they have a lot of energy and can penetrate matter. They are given out when either alpha particle or beta particle is being emitted. So whenever an alpha particle is being emitted or the beta particle is being emitted, which means the gamma rays will also be emitted there. Okay, so the characteristics or the features, they are neutral. They are very neutral. Neutral means zero. They have no charge. Okay, they have zero mass. Okay, they have their ionization and their ionization energy is very weak, and they have high penetration. They can only be stopped by a reed box. From that point, we can say a gamma ray will penetrate through the paper, penetrate through the aluminium foil or aluminium sheet, but can only be stopped by the lead box. Okay, so this is what we can discuss for today's video. Make sure you subscribe to my YouTube channel. Next lesson is coming. The next video we are going to discuss on half-life. How do they decay under alpha particle, how do they decay under beta particle. Then we'll go on to the graph of half-life. Then we'll be done with this topic. Okay, thank you very much. Make sure you subscribe to my YouTube channel, Simple Science. Okay, this is just a summary of the characteristics of types of radiation. We've got alpha particles on top. We've got alpha particles on top. Okay, so okay, so you can see there where may I get a pointer. I get okay. Okay, we can see there. The alpha particles, it is saying here under nature, 2 protons, 2 neutrons, deuterium, nucleum, positive 2. Then beta particles, it has got electrons, which is negative 1. Then X-rays, electromagnetic wave, as I mentioned earlier. Then approximate mass is 4 mass, 1 over 1800, and that is 0. So that is just a summary of the characteristics of the 3 emergent particles of what? Of radiation. So here we've got diffraction by electric field. You find that the beta particles is diffracted first by the electric field, and there the alpha particles, there the gamma rays. Here we've got there how the diffraction is under magnetic and electric field. Thank you very much for watching this video. Remember to subscribe to my YouTube channel so that you'll be watching more videos. We are in the pandemic, the lessons are not going forward, therefore you need to be watching my lessons so that you catch up with the syllabus. Exam is just nearby, around the corner. Thank you very much, and we apologize for the video quality. The next video we are going to improve on my video quality.